Let's take a look at verifying or proving trigonometric identities. This is a topic that when I used to teach trigonometry course, the kids would just complain about this and wonder, how the heck, Mr. White, do you even know how to start? And the answer is, it comes from experience and seeing lots of problems. So the best thing you can do is do all the problems that your teacher assigns you. Make sure you understand that some of them could be done multiple different ways. But I'm going to go through the strategy on how to approach a proof or a verification of an identity. So when you see the word verify, what that means is the statement is true and you're supposed to prove it. Now, sometimes the directions will say prove the following identity, and it's the same as verifying. Okay, so those are the same thing. So in your class, you just got done learning all about trig identities and substitutions that you can make, right? You were working on simplifying some of those, and I'll make a video on simplifying as well. So you have this library of knowledge now. And so I've put a little cheat sheet off to the side on each of the problems that we're doing today, so that we can refer to that if we need to. So you probably have some sort of a formula sheet that your teacher gave you, so you want to always have that out while you're working on it, and most teachers will let you use that on your test, so I hope your teacher will as well. So let's go through these quickly, okay, because you have been working with these, so these should all look familiar. So the first few are called the Pythagorean identities. Sine squared plus cosine squared is always 1. So anytime you see a sine squared plus a cosine squared, you should get a little excited because you can just cross it out and put a 1 there. Now there's 2 offshoots, and we're going to be using these a lot, so I want to write them down. At least you should write these down on your formula sheet as well. Cosine squared, all by itself, if you subtract that sine squared to the other side, you'll get 1 minus sine squared. Okay, so 1 minus sine squared is cosine squared. So anytime you see 1 minus sine squared, you can replace it. All right, we're going to see that some today in this video. Sine squared, similarly, is 1 minus cosine squared. So those two you should be familiar with. Those are just offshoots of sine squared plus cosine squared equals 1. And then this one has an offshoot. 1 plus tangent squared is secant squared. So if we subtract the 1 to the other side, we get secant squared minus 1 is the same thing as tangent squared. So I'm pretty sure on some of these problems, oops, I'll put an X here. I usually use X's and not thetas. So secant squared minus 1 is the same thing as tangent squared. We might see that in some of these problems here in this video. And then also, if you subtract 1 on both sides, you see cotangent squared is the same thing as cosecant squared minus 1. All right, so these down here are the symmetrical or the odd-even identities. Whenever you see cosine of negative x on the inside, you could actually replace it with cosine x and so on. So you probably are aware of those. I squeezed a couple really important ones over here. Whenever you see sine over cosine, you could replace it with a tangent. Or whenever you see tangent, you could replace it with sine over cosine if you want to. Same thing with cotangent. Cotangent is cosine over sine. Again, you probably know all these, but I just wanted to set the stage for our proofs here in a second. And then I'm not going to go through all these, but you know that sine is the reciprocal of cosecant. Cosine is the reciprocal of secant, and tangent is the reciprocal of cotangent. We will be using those in this video. All right, so there's our arsenal of knowledge, as I'm calling it, and we're going to use these facts to solve different proofs. We're going to verify that this is true. For example, on this first one, I tried to pick something pretty simple to start out with. We're going to prove that tangent times cosine is equal to sine. How do we do that? Well, one of the strategies, before I say that, let me just say, you can never divide both sides by something, multiply both sides by something. You can't work it like an equation. You can choose to work one side and try it like I'm going to get the left side to equal sine, and then I will have proven it. So let's go ahead and dig in here. We're just going to work the left side and turn it into sine, and then we'll be able to say, yeah, we've proven what we set out to prove. So what could we do here? One strategy, and you saw this when you were simplifying, is just convert everything to sines and cosines and then see where things fall. So remember that identity. Tangent is sine over cosine. And I'm not going to do anything with the cosine. I'm just going to write it as cosine over 1. I'm going to write it cosine over 1 so you can really clearly see that we have a cosine on the bottom, a cosine on the top, and they cancel, leaving behind sine. Well, what do you know? We've proven that the left side is equal to the right side, so you could put a check mark there. I always had my students write QED, and I looked at it about an hour ago. I'm trying to remember what that meant. It was like quod erat demonstratum or something like that. It means, in Latin, I have demonstrated what I set out to demonstrate. I have proven what I set out to prove. It's Latin, and it's very common to use at the end of a proof. I remember using that in geometry class when I was in school. We would write that, and it's basically a mic drop that you've done it. You've done it. Yeah. Okay, so let's move on to the next question. I think I have about 5 of these lined up, and they get sort of increasingly difficult as we go along. Of course, your teacher could give you like 30 of these, 50 of them. All right, there are so many of these problems that can be dreamed up, maybe an infinite number. So I've just tried to pick some that demonstrate different aspects of the tricks, because you got to learn the tricks. That's where I said earlier, you got to just do the problems. You got to get some experience under your belt to know how to approach them. All right, the left side here is secant over tangent. And we're going to prove that that equals cosecant. Your teacher probably told you a strategy is to always take the side that looks the ugliest and try to simplify it. So I think the left side looks a little crazier. So let's see if we can turn the left side into cosecant. So fractions are actually division problems, aren't they? Fractions are division problems. So I'm going to write this as secant divided by tangent. Okay, which of course is 1 over cosine, right? Remember that reciprocal identity? Let me zoom out here. Remember that over here? Secant is 1 over cosine. It's right there. All right, so I replaced it in there. And we're dividing that by sine over cosine. Now think back to middle school when you learned how to divide fractions. What do? You multiply by the reciprocal, or a lot of students like to say keep change flip. So we're going to keep the first one the same. There is no cross multiplying. I hope you didn't say that. Times, and then I flip over the second one. Okay, and then you multiply the top, multiply the bottom, and see what happens. But before that, you can always cancel. I see a cosine on the top and bottom. Anytime you have something on the top and bottom that match, they cancel, leaving behind 1 over sine. Oh, my goodness. That is cosecant. Look at that. Put a little check mark, QED. We've proven what we set out to prove. So all of these things were the left side. So generally, I don't recopy the right side until the very end if I'm working just the left side. All right, so we've proven this identity by rearranging and simplifying the left side and showing that the, quote, answer was cosecant. All right, is this hopefully making sense how we approach these? It takes experience to know how to just jump in and start working with it. So this I saw was a fraction, so I treated it as a division problem. The keep change flip, going to sines and cosines, I saw how it all played out, right? Okay, here we go. Number 3. 1 minus cosine squared plus 1 plus cotangent squared is equal to 1. Wow, well, that's pretty cool. We're going to prove it. We're going to verify it. All right, so I'm pausing. I'm taking my time so you can think a little bit. What do you see anything there that can be done? Where would you go on this? You know, you could FOIL it out, but boy, that would make a giant mess, right? We'd have a whole bunch of ugliness. Do you see anything on our formula sheet over here? Well, yes, of course. Remember earlier I said 1 minus cosine squared is sine squared. And then I said, it's right here actually on the formula sheet. You could see that, right? Yep. 1 plus cotangent squared is cosecant squared. And you might be thinking, well, how's that help me? What do we do next? What's cosecant? Cosecant is 1 over sine. So the fuchsia, the pink side here, is 1 over sine. And then the first one here is sine squared over 1. So we have a sine squared on the top and bottom. They cancel. 1 equals 1. We're done. QED. Mic drop. We got it. We did it. Okay? So always be looking. They come up all the time, folks. Trying to find my highlighter here. They come up all the time, and that's the 1 minus cosine squared and the 1 minus sine squared. Look for those all the time, and then also these two here, or those other two that I wrote on that other problem. So let's continue on. Look at this mess. Oh my goodness. What do you see here? Do you have any ideas on what we could do? First of all, which side is the bigger mess? I don't know. They're about the same, aren't they? They're kind of crazy. They both have something -1 and all that kind of garbage. So you know what? We're going to do this one a little bit differently. And we're going to work both sides, but we're never going to add something across. We're never going to multiply something across. You have to treat it like there's a line down the middle here. Okay? So what do you see on the left side that could be simplified? Secant squared minus 1. That sounds familiar. Do you remember on that first slide, this one right here told us that tangent squared is secant squared minus 1. That comes from that second identity. If you subtract 1 on both sides, you see tangent squared is secant squared minus 1. So make sure that's on your formula sheet. So this is tangent squared over sine. Now on the right side, I'll do it in a different color. You're probably screaming at your screen, right? Because you're so engaged, you're enjoying this. It's good times with Mr. White. 1 minus sine squared is cosine squared. Okay, well this is kind of looking like a mess still. What would you do next? Where would you go? I know where I'm going to go. I'm going to change that tangent to be sine over cosine, and I'm going to treat both sides like a division problem. Actually, I'm going to leave the red side, the right side, the way it is. So let's rewrite the black side, the left side, as sine squared over cosine squared divided by sine, and that would be on the top. And then you do your keep change flips. Now we have sine squared x over cosine squared times 1 over sine. We're going to cancel this sign with one of these, just one of them. What does that leave behind? That leaves 1 sine on the top, sine to the first power. 1 factor of sine is why I say 1 sine. So sine to the first, and then we have cosine squared on the bottom. Well, look at this. On the right side, that's what I had. So QED, we've done proven what we set out to prove. So you're allowed to work both sides, at least in my opinion. Maybe your teacher disagrees, but you're allowed to work both sides and try to get them both down to something more simple. Certainly, we probably could simplify both sides more, but we don't need to. We've proven that the left side can be turned into the right side. Okay, I think I have one more here for you. Actually, there may be another one. Let me remember here. Oh yeah, we got two more. I was thinking the last one was a blank slide, but we got two problems. I thought there was another good one I wanted to share with you. So on these next two, I got to show you some tricks of the trade, some mathemagic tricks that Mr. White has up his sleeve to solve some of these things. So 1 minus cosine x over sine, I guess, is equal to sine over 1 plus cosine x. So I'm looking at this, and I'm trying to think out loud to give you a little indication on how I approach these. I see that there's a plus here and a minus here, so how am I going to turn a plus into a minus? And how am I going to flip it over? Well, that seems to be two different things. So how am I going to introduce a minus on the right side? I'm going to multiply by something divided by itself. And I'm going to use the conjugate. The word conjugate means you change the sign. So instead of 1 plus, it's going to be 1 minus cosine x. But remember, I'm multiplying by something over itself. So I have to put the exact same thing on the top. Okay. Now, I'm going to rewrite it. Sine x times the quantity 1 minus cosine x. Sometimes you do the distributive property there, but I don't think I want to. Let's see what happens. All over this, I got to FOIL that out. That is a sum and difference pattern. 1 plus cosine, 1 minus cosine is 1 minus cosine squared. Oh, that was on our formula sheet. 1 minus cosine squared is what? Sine squared. So we have sine x over 1 minus cosine all over sine squared. Aha! Now we can start canceling things. By the way, I guess I really should have said earlier, on canceling, you can only cancel factors. I often assume that students remember that, but students try to cancel so many things that they're not allowed to. I mean, teachers are like nodding their head up and down right now. Yes, they do. So, for example, if you have 1 plus sine over 1 minus sine, some students really want to try to somehow cancel those things, and they do not. You cannot do that, folks. It's an all or nothing thing, and those two don't match, so there's nothing that cancels. All right, so I just wanted to say that because I do see that error. Someday I may make a video of the top 10 things that drive me nuts as a math teacher, and that would be high on the list, is canceling things that you're not allowed to cancel. All right. Sine x cancels one of the sine x's on the bottom, leaving one behind. So let's rewrite it. 1 minus cosine x is left on the top, and sine is on the bottom. Hallelujah. We did it. That's the same thing that's up here. We transformed the right side into the left side. So I like to put a check mark there just to show that I knew what I was doing, and you can, if you want to write QED, you can explain. You look that up on Wikipedia, and you'll find out how to pronounce it and what it means. But it means I've done proven what I set out to prove. All right, mic drop. One more question with one more trick. So the trick in this problem, let's reflect back a little bit, was that conjugate. I wanted you to see one of those because by using the conjugate, it gave us a 1 minus cosine squared, which allowed us to turn it into a sine squared. And that was really helpful, as you saw. All right, one more example. Oh, my goodness. Two fractions on the left side. One is 1 minus cosine, and the other one is, and the other is 1 plus cosine, and it's all equal to 2 cosecant squared. So, what can we do here? What can we do to solve this? I think since this is one term, right? It's just one term. I think we need to add these together. And you did that with x's recently, probably a few weeks ago in your algebra class, if you're in algebra right now working on this. Or maybe it was last year. Or maybe it was earlier in your pre-calc class. But either way, you know how to add fractions. you know how to add rational expressions. You have to get a common denominator. And you can check my channel for some videos on adding and subtracting rational expressions, because I do have some in there. What we have to do is upgrade the fractions so that they match. So this needs a 1 plus cosine. Whatever you do to the bottom, you do to the top. 1 plus cosine. This one needs a 1 minus cosine. 1 minus cosine. You see now the fractions have the same denominator. If I zoom in here, you see that they have the same denominator now. 1 plus cosine, 1 minus cosine. And the top was just along for the ride. Since there's ones on the top, we don't have to do any distributive property, but if those were numbers, of course, we'd have to launch our little missiles and do our distributive property. So we get 1 plus cosine plus 1 minus cosine. Oops, I forgot my x there. That's a pet peeve of mine. Sorry about that. All over 1 plus cosine, 1 minus cosine. See, we had a common denominator, so we can boil it down to a single fraction. All right, what happens on the top? What do you see? I'm going to get my fuchsia canceling color here. Cosine and negative cosine add up to be 0. So they cancel. They add up to be 0, so they're gone. And 1 plus 1 is 2. Right? We all agree, right? 1 plus 1 is 2. All over. And then I'm going to FOIL this out. I'm going to multiply it. We saw this earlier. That's a sum and difference pattern. So 1 minus cosine squared. Ah, you getting excited? You see where this is going? You start to see the substitutions that we can make, don't you? 1 minus cosine squared is what? Sine squared. Okay, and then let's go over here. Sine squared is cosecant, the reciprocal, sorry. So cosecant is when there's a sign in the bottom. It can be written as a cosecant, and I think that's what we have here, don't we? Let's see. We have a sine squared in the bottom. So yes, indeed. This would be 2 cosecant squared. And if I zoom out here, that equals, that equals 2 cosecant squared x, just like we wanted to have happen. So I wanted you to see an example where I had to really do a lot of work on one side. I had to add the two fractions. Once again, we ended up with that 1 minus cosine squared, and that helped a lot. So hopefully you found this video useful. Let me go back here. Don't forget to like and subscribe this video to this channel if you indeed did find this helpful. I try to post quite a few. I've got quite a library of videos that I think could really help you. I'm going to try to build out my trigonometry stuff. I have stuff on, the trig functions and how to use them, but I need to do some more on all of this fun stuff here. So hopefully you found this useful, and if you have a quiz coming up, good luck. Make sure you have your formula sheet out. All right, well, until next time.